Hello everyone, welcome back to this new tutorial, and in this new tutorial we'll study about the cumulative frequency, right? Cumulative frequency graphs. So here we are right now in at Excel Pearson Mathematics for IGCSE, and the page number is 292, and it's unit 4 in data handling 3. We are here at exercise 2, and we are studying this question which is given in front of us. 120 people were timed on how long they took to complete a puzzle. The cumulative frequency diagram shows the results. So cumulative frequency is the frequency in which the total frequency is added up. For example, from 0, 20, 40, right, 60, 80, 100. So the frequency is plotted on y-axis or on the vertical axis along this, and the endpoints or the data points are plotted on horizontal axis. So the time of the people they take to complete the puzzle is here. So when the time was 10, so the frequency was something like here at this point. So you can just compare it here and then just count how many were there. One, two, maybe two. So you can see from here, so after the time is 20, it's moving very steep up, right? So the number after 20 minutes, the frequency is getting increased. So in this type of question, so how can we estimate the median time and interquartile range? So first is the interquartile range, and is we know that the interquartile range is we find IQR is Q3 minus Q1, and when the data points are quite large, then how can we find the Q1? It's like we do not need to do n plus 1. So for Q1, what we can do is 1 by 4 times n, right? So we do not need to do n plus 1 when the data points are huge. And this gives us, so the n is the number of observations. N is the number of observations. So here the total people are 120, right? So 120, that means 120 over 4, and that gives us 30. So 30 is our Q1. So we will plot here the Q1. This is 20 here, and this is 40 here, right? So 1, 2, let me just zoom it out so that maybe we can see it better. Yeah, so 1, 2, 3, 4, 5. So here at this line it is 30, right? So we'll just cross it here, okay, and bring it down to this point. So the time here from this point to this point, it's 30. So you can say that 20, 21, 22, 23, 24, 25. So this point is 25, and this point here is 21. So this is our Q1. Okay, so now the Q2, Q3 will be, Q3 is 3n over 4. So that makes us, yeah, 30 times 3 is 90. So we'll just have a look at the center. 90 is here, Q3. This one, my line is not very straight, so let me draw it again, and let me try to be a little, okay, this time it's better. Here it's 29. This is our Q3, and for Q2 or median, Q2 and median are the same. So what we can do here is n by 2, that is 120 by 2, that gives us 60. So at the 60 is our, yeah, so this is here. So in term of when we see the minutes, so 60th frequency is, so along the 60, it is at 25:26. So our median is 26 minutes. Okay, our Q3 is here 29 minutes, and our Q1 is 21 minutes. So by this, we can very easily estimate the median time. So the median time is 26 minutes, and IQR is equal to uh, Q3 is 29 minus 21 Q1, and that gives us 8 minutes. So this should be our answer. Okay. Now let's go to the next question, and in this question the cumulative frequency graph shows the height of 80 plants. The total number of plants are 80, and what is the range of heights? So the heights have been given here from 0 to 60. So when the range of the height, so it's the same, range is, as we have discussed in previous videos, 60 minus 0, that gives you 60. What percentage of the plants were taller than 45 centimeter? Okay, so 45 centimeter you can just have here. Okay, so 45 centimeter, 40 and 50. 45 is this one. Okay, so if you plant it up here along this line, 45 here, you can see. So the cumulative frequency, it shows 60 61, 62, 63, 64, 65. Okay, so here one square represents 2 points. Okay, because here this one is 70. There are five squares between 60 and 70, so that shows that one square represents just 2 points. So there are four, so that means 64. So from 64 to 80, right? So the cumulative frequency we can see here, and what percentage of the plants were taller than 45 centimeter. So from 45 centimeter, you can just see a total number of plants were 80. So there were 80. So what were the height? It's here at this point. The highest point is here, the 80, yeah, this one. Now 50 and 60. On the horizontal axis, you can see here that from 50 to 60, there are 10 lines. 1, 2, 3, 4, 5. So one line represents, yeah, 55. Okay. So the highest were 55, and from 45 to 55 centimeter, and on the cumulative frequency, if you see from 64 to 80, they were higher than, right? So 64th one is the one 45. With the 45 they are 64, so you do not need to calculate the 64. You should uh, minus from 65 to 80, these are 15. So 15 out of 80. So there were 15 plants, okay, higher than, taller than 45 centimeter were 15 plants, but it asks you what percentage of the plants. So you had total 80 plants and 15 out of the 80 were taller. So you have to see that what percentage of these 15 are, so that you can calculate by 1500 divided by 80. So that makes you 8 ones are 8. If you solve it by 4, 4 twos are 8, 4 sevens are 14, okay, 2 fours are 8, 2 sevens are 14, 2 5, 75 divided by 4, 7 ones are 7, 4 ones are 4, 3, 8s are 32, okay. So 18.7, or you can say 19 plants were 19% of the plants 19% of the plants were higher than 45 centimeters. We go to the next question. Tomatoes of two different varieties, X and Y, are weighed. The cumulative frequency diagram shows the frequency distribution of the weights of the two varieties. How many tomatoes of variety X were weighed? Okay. And estimate the minimum and maximum weights of tomatoes from variety Y, variety X, maximum weight and minimum weight. Work out the median and the interquartile range for the tomatoes from variety X. How many tomatoes of variety Y were weighed? Estimate the minimum and maximum of Y and work out the median and interquartile range compared to giving the reasons for any statements which you make. So the first, we can look at this data. The weight in gram is given from 0, 150, 160 like this, and 210. And here the cumulative frequency is here. First is how many tomatoes of variety X were weighed. So variety X, how many tomatoes? So here this is the point, and if you look at this one, this line, so here 80, yeah, cumulative frequency, so 80, and the weight, if you want to say see their weight, in frequency was 80 and the weight was 200 and 210, right? So this is 205 and 205 gram was each its weight. In total 80 were the frequency. 80 tomatoes of variety X. 80 tomatoes of variety X were weighed. Estimate the minimum and maximum weight of tomatoes from variety X. So the minimum weight was for the X here, the minimum was 145, 100 in its middle between 160 and 150, so it should be 155. 155 gram was the minimum and 205 gram. Okay, so it was 150 to 205 gram. Median and the interquartile range of tomatoes. Median and interquartile range. So the total were 80. So the median was 80 divided by 4. So it was like 20. Okay. 20 and 170, 75, 76. So 20th was the median, 20th tomato was the median, and its weight was 100, and the median weight was 176. Median was 176, and int, sorry, it's not median. This one is Q1. And okay, Q1 is equal to 20th tomato, and its Q1 was 20th, and its weight was 176 grams. Q2 was this one, it's number 40, because it should be n by 2, so n is 80, so it should be 40th. So the 40th tomato was, for the red one, here 85, 86, 186 gram. And Q3, this all is for X, and Q3 was 3n over 2, and n is divided by 80 divided by 2 is 3n divided by 4. Okay, so this gives us 60th one, and 60th one is here. One hundred and 91. Okay, I draw all this, the values of x with a green line, and now I'll change the color to the red one or blue one. Yeah, the color to blue one for the blue. How many tomatoes of variety of Y were weighed? So the Y were here 100, and here it was 210. Right, so total Y were 100, and estimate the minimum and maximum of Y. So the minimum were here, minimum weight was 160 gram, and maximum weight was 210 gram. The next question is, work out the median and the interquartile range. So for interquartile range, first we find Q1, and Q1 would be formula n by 4, and n is 100. 100 by 4 is 25, right? So we'll see a 25th one, 20, and this one is 40. So how many lines are there between 20 and 40? This line is quite thick, so let me draw it again. 25. So 20, and this one is 30, and 1, 2, 3, 4, 5, right? So 25. 1, 2 and half. It should be somewhere here. This one. Okay, I was doing with green one, so let me switch to green one and erase this one. Okay, so this is the 30, 25 is Q1, and Q2 is 850, and Q3 is Q2 is 8, n by 2 is equal to 850th value. Q3 is 100 times 3 by 4, 300 over 4. Okay, and 4, 7 are 28, and 2 is carried here, 75th value. So Q3 will be 60, 70 and half. Okay, so this is 75 Q3, and here against the 75th, eighty to 90, 1, 2, 3, 4, 5, 6, and 9, 10. Okay, 80, this one 81, 82, 83, 183, and this one is 84, 85, 86, 186, and this one 170, 74, 75, 76, 77, 78, 178. Okay, so the Q1 is Q1 is a 25th value, and the 25th value is 174, and Q2 is the 50th value, and the 50th value here is 178, and Q3 is 75th value, and that is 183. Okay, so yeah, the IQR will be 183 minus 174, that will be 9. 9 grams is the area. So the IQR for this one is 9. And the IQR for the previous one is Q1 191 minus 176. The previous one, IQR of X is equal to 191 minus 176. Okay. 15 grams. Compare the two varieties giving reasons for any statements which you make. So for Y, the IQR is 9 gram. That shows that the values in the Y are very compact. The 50% of Y are in among 90 grams. 90 grams. And here you can see 15 grams. In X, 50% of middle values covered in 15 grams. So that shows that the spread for X type of values is long, whereas compared to the Y, and it is represented by the graph as well. The graph for the the blue ones is quite, it's very vertical, it's very steep, whereas the red ones is not very steep. So for the red ones, the data is like they have more spread for the middle 50% as compared to the blue ones. And if we see the median of both of them, for the X ones, this is Y values and these are X values. For X ones, it's here, For the X1s, the Q2 or median is 186 gram, whereas it is 178 gram. So the median overall, the center value for X is increased. So that shows that the X type of tomatoes, they are more heavier. Overall, they are more heavier, right? But the X1 have a lot of spread in their uh, middle 50%. They have a separate among 15 grams, whereas the Y1s, their middle value is 178. That's less than the X1s, but their spread is quite less for the middle 50%. Okay, so if we have to plot it on a box plot, how would we plot them? It would be like the minimum one and the maximum one. Okay, for the minimum, it's first, let's do for the X1. For the X1, the minimum is here 155. Okay, and the maximum for them is 205. And if we see the interquartile range, they are spread from 155 to 205. And Q1 here for them is 176, 186, and 191. 176, 186, and 191. Now I draw for the Y1s. Their spread is 160 and maximum is 210, and their spread is 174, 178, and the last one is 183. Q3, Q2, Q1. So now we can compare it better. If you see the spread, the 50%, the data in this box is the middle 50%. So the middle 50% here is spread from 176 to 191, right? Whereas here the data is spread from 174 to 183. So this shows that the Y values are compact. They do not have much spread for the 50%, and the median for the X values is at higher as compared to the Y values. Here you can see 186 and 178, but overall the maximum height is less for the X-axis. So this you can draw comparisons from this graph. So here is the last question for this exercise 1, and it says the cumulative frequency graph gives information about how long the batteries last in two different types of mobiles. Use the graph to find the median and quartiles for each type of phones. Compare the two phones. So here are two types of phones, phone A and phone B, and we have to find the total number for both of them is very similar. Let me just make the graph bigger so that we can have them a better look. Time in hours. So the number of phones, if you say, first we have to see the cumulative maximum frequency in hour, and it is at 12, right? So the total 100 phones, and the time they all can be used are that their battery time. So the battery time of both is 12. Okay, now the minimum for the type A or the red one is 3 here. The minimum time they have 3, whereas the blue one, the minimum time they have 4. And for example, if we for the red ones we draw with the red ones, and if we divide it with 100, so the 4 quarters become 25%, 50%. Yeah, the 50% for the red, it comes here at 8 hours, and 75%, it's not very complicated because it's already given in percentages. So 60, 70, and 75 is the quartile here for the red ones. You can see here it's 9 point between 9 and 10. 1, 2, 3, 4, 5, right? 1, 2 means 4. 9.4 is the hours for the red ones upper quartile, and the lower quartile will be in 25. 7. Okay, so 7 is Q. This one for the red is Q3. This one for the red is Q1, and this one is medium. This one is maximum, and this one is minimum. So median time for the red A median is equal to 8 hours, and their IQR interquartile range is 9.4 minus 7. 2.4 hours. Now let's calculate the same for the green ones. Since the frequency is the same, so I just use the blue pen here. It has the same maximum is same 100, the minimum is 4, and for quartiles it's the same here except this one, right? So their Q3 is here. Okay, at 8 it's the Q3. For blue ones at 8 the Q3, and their 50% or Q2 is here 6.8. 1, 2, 3, 4, 5. Yes, 6.8. Q2 is 6.8, and the Q1 is 5.1236. 5.6 is Q1. Okay, so now we can calculate B type median is 6.8, and the IQR is 8 minus 5.6, 3 point, no, it's 2.4. Okay, so the interquartile range of both of these is same as we can see here, but the median of A is more. It is a more time of 8 hours, whereas the median time of B is less. So if you want to further investigate it, you can draw the IQR on the box plot, and with the box plot you can have a clear idea about their time. So thank you very much, and I think this exercise finishes here. So if you like this exercise, please like this video, share this video, and we'll continue to study